This lesson, 2-6, Algebraic Proofs, is going over basically a proof, a two-column proof, and how to set one up, which we've already reviewed in the UNO video, the UNO proof video. But we're going to kind of go through it quickly. I do have the notes posted here, the blank shell of notes. And normally when I teach this lesson, I go through and fill out all the notes, and they end up looking something like this. But I think probably you guys would agree with me that instead of spending the time it takes to fill all of this out, we would rather just get right to it, right? Start using what's in the lesson and not just writing all about it. If you would like to write it, I am going to put my filled up notes as well, so you can jot down, print out the blank ones and jot them down if you'd like. But I'm just going to kind of cut to the chase and use this study guide to get to the meat of the lesson. So 2-6, study guide and intervention, algebraic proof. Algebraic proof is a list of algebraic steps to solve problems where each step is justified. The table shows properties you've studied in algebra. We are going to use these. So yes, you should already know these. You've used them in algebra. Even if you don't call them by name, if we don't call it the addition property of equality, every time we're solving an equation for x, we know that if you add something to one side of the equal sign, you have to add it to the other, right? We do that all the time. We just don't call it this. So you should know all of these. We're going to use them to write proofs. So the addition property of equality is whenever we add something to one side of an equal sign, we have to add it the same exact thing to the other side to keep the two sides equal. All of these are properties of equality. Whenever you do something to one side of an equal sign, you have to do the same thing to the other side to keep them equal. So we also have the subtraction property of equality. If I subtract a number from one side of my equal sign, I have to subtract the same thing from the other side. Multiplication, if I multiply one side of my equal sign, I got to multiply the other side. And division, same thing. Whatever I divide one side by, I have to divide the other side of the equal sign by that as well. All right, the three, and we're going to kind of focus more on the back side of the notes here, but these three properties right here get a little tricky because they seem really, really similar. So we have the reflexive property of equality, the symmetric property of equality, and the transitive property of equality. And we're going to focus on those three on the back. We also have the substitution property of equality and the distributive property of equality. We know distributive property is whenever we have parentheses with a number right outside the parentheses, we distribute that number outside the parentheses to get rid of those parentheses, right? We didn't change the value of anything, we just changed the way it looked. So everything still stays equal, we just get rid of those parentheses by distributing. So that's our distributive property. Substitution is the one that we probably use the most often, okay? All these other properties of equality, basically if you touch one side of an equal sign, you've got to touch the other side too. You're working on both sides of your equal sign. Substitution, usually that's not the case at all. Usually substitution is where maybe on one side of an equal sign, you'll have 2x plus 3x equals 5. And so in the next step down, you would just combine the like terms and you'd write 5x equals 5, right? So we didn't do something to both sides of the equal sign. We just combined like terms on one side. That's substitution. So basically, when none of the other properties fit, if you're not sure what property to use and none of the other ones work, it's always going to be substitution. That's our default. Okay, so we're going to focus on these top guys here. I don't think on this front side we'll get into these three, but we will on the back for sure. The first example here is just solving an equation. So it says solve this and write a justification for each step. When we write our two-column proof, our justification is that right-hand column, our reason column. So each mathematical step is our statement. That goes on the left side in our two-column proof. And then each reason or each rule that we use is our justification, and it goes on the right-hand side. And I'll show you what I mean in a second. So here we're solving this guy. We're trying to get x alone. So the very first thing we do, this is the given. This is our original equation, so we just put given over here. First thing we need to do is get rid of parentheses, so we're going to distribute that too, right? So the next line down, we've distributed. So that's the distributive property of equality. And they just wrote distributive property. You don't have to write property of equality every time. Okay, then from this step to the next step, it looks like we took 6x plus 2x and we changed it to 8x. That's all we did. We didn't do anything on this side of the equal sign. 30 stayed 30. So this is substitution, the substitution property of equality. Okay, then from this line to this line, we're trying to solve for x, so I had to get rid of minus 2 by adding 2. And whatever I add on one side of my equal sign, I have to add the same thing to the other side of the equal sign. So since I'm adding 2 on both sides, that's the addition property of equality. And then in the next line down, I need to go ahead and add them, right? Negative 2 plus 2 is just 0. They cancel out. These go away. And then 30 plus 2 is 32. So I end up with 8x equals 32. And going from this step to this step is just substitution. I just simplified. I'm going to put simplify. Simplify is not a justification. You can't write simplify in your proof. But substituting is simplifying. They're the same thing. So just understand, if you're going to simplify, the reason is always substitution. Then going from 8x equals 32 down, I have to get rid of this 8, so I need to divide by 8 on both sides of my equal sign, which we do here, and that's the division property of equality. So we show that we're going to divide, now we actually need to divide. So these 8's cancel, and 32 divided by 8 is 4. So we end up with x equals 4, and that's because I simplified, so that's substitution. Okay, so this is all we're doing in our 2-column proof. We're just actually adding the little t guy here, and we're writing statements over here, reasons over here, and then keeping it exactly the same. So that's what we're going to fill in the blanks on here at the bottom. I feel like doing examples with you guys is helpful. When I learn, it helps me to just actually jump in and do a problem to see, you know, where I'm gonna maybe need help on. Okay, so the very first line is always the given. I don't even have to read anything yet, I just know it's the given. So it tells me that the given is 4x plus 6, all divided by 2, equals 9. And I have to work my way down to saying that x equals 3. I have to prove that x equals 3 if this is my original starting point. Okay, so here's my proof. My facts or my math steps are here on the left, and all my rules that kind of tell why I used each math step go here on the right. That's it. All right, so here's my given. All right, so what do I need to do first here to try and get x alone? Well, the very first thing I notice is that both sides need to get multiplied by 2. I need to get rid of this denominator. So I'm going to multiply the left side by 2, and whatever I multiply the left side by, I have to multiply the right side by the same thing. So that's the multiplication property of equality. They didn't even write it all out, right? They just abbreviated. That's perfectly fine. And so then going from line to B to C, we actually have to simplify, right? So these 2's cancel out, and I'm left with 4x plus 6 equals 2 times 9 is 18. So when I simplify, that's substitution. Don't write simplify in the blank. Yes, that's the reason, but we use the rule substitution. Okay, then going from C to D, I'm still trying to solve for x, so I need to get rid of this plus 6, so I'm going to subtract 6, which they do, which they do here. And whatever I do on one side of my equal sign, I have to do the same thing to the other side. That's the subtraction property. I'm going to abbreviate subtraction property of equality. Okay, and then once I write that out, I actually need to follow through with it. So if I have 6 and I subtract 6, they cancel out. So I'm just left with 4x on this side of my equal sign. Bring down my equal sign. 18 minus 6 is 12. And then that act of simplifying is substitution. Okay, so now I've got 4x equals 12. I just want to know what x equals, so I need to get rid of that 4 by dividing. So I'm going to divide this side by 4. And whatever I do to one side of my equal sign, I have to do the same thing to the other side. So I'm dividing 12 by 4. That's the division property of equality. And then lastly, I actually need to simplify that. So these 4's cancel, and I'm left with x equals 12 divided by 4 is 3. And whenever I simplify, that's substitution, that reason. So these are all my math steps in order, and these are all my rules that I used to explain why I did each step, right? And then number 2. Should I focus in? I don't want to focus on my hands or my handwriting, but I can read that a little easier. There we go. Okay, given 4x plus 8 equals x plus 2. I notice I've got a variable on both sides of my equal sign. I have to prove that x equals -2. So I am just solving for x is basically all I'm doing. So I start off with my equation, the first reason, and if you don't remember this, make sure you go back and watch the very first video I posted in this folder about the Uno cards. That'll help kind of simplify and explain in a way that's easy to understand what a proof is. So everything I do goes here on the left, and all the rules that I used, the reasons why I did these things, get listed over here. That's it, statements and reasons. So my very first line is always whatever I start with, the given. Here's my equation from the given. The reason I started with that equation is because that's what was given. Okay, now I'm trying to solve for x, so I know that whenever I have a variable on both sides of my equal sign, I always get rid of the smallest. So I would need to subtract x from this side and from this side. So in step B, they subtract x from both sides of the equal sign. Now they just show that they're going to, they haven't done it yet. So that act of subtracting the same thing from both sides of our equal sign is the subtraction property of equality. We're just going to say subtract prop. And then in the next line, I actually do it. I actually subtract. So 4x minus x is 3x. And then on the other side of the equal sign, these x's cancel. So I end up with 3x plus 8 equals 2. And that act of simplifying is substitution. I'm just writing simplifying here so you know why. You do not ever write simplify. You always write substitution. Okay, the next thing I need to do now to get x alone is to get rid of this plus 8. So I need to subtract 8 from both sides of my equal sign. So I start off with 3x plus 8, and then I need to, oh, where's my red pen? I need to subtract 8 from that side, and I also need to subtract 8 from this other side. So I'm subtracting the same thing from both sides of my equal sign. That's the subtraction property of equality. And then in the next line down, I actually simplify, right? So these 8's cancel each other out. 8 minus 8 is 0. So I'm just left with 3x. Bring down my equal sign. 2 minus 8 is -6. And so that act of simplifying from this step to this step is substitution. And the next thing I need to do here is get rid of this 3. Right now it's x times 3, so to get rid of times 3, I'm going to divide by 3. So I got to do the same thing on this side of my equal sign. So they show this here. When I divide both sides to keep both sides equal, that's the division property of equality. I'm just going to write the division property. And then I showed I was going to do it, so in the next step I actually have to do it. The 3's go away, and I'm left with x equals -6 divided by 3 is -2. And that act of simplifying is substitution. And you do always want to make sure that your very last line here, we don't write prove over here. We always have to have an actual rule over here. But this last statement has to match the prove. They always have to match. If they don't match, then I didn't do something right. They always have to match that last line. Okay? Hopefully that helps. The second page of this study guide. I love the study guide worksheets because it is basically the entire lesson simplified or condensed down into one sheet of paper front and back. Okay, so we're focusing now on the reflexive, symmetric, and transitive properties that we saw on the front of our paper. These properties are listed just like the other properties on the front. All these 1, 2, 3, 4, 5, 6, 7, 8, 9 properties, you have to know that. Like they could be on your next quiz or your next assignment and definitely will be on your test. So you do need to work on memorizing these. Shouldn't be hard because like I said before, this is stuff we do all the time anyways, but you do need to know the name of each thing. So the hardest ones that are going to, the ones that are going to be hardest to remember are these three: reflexive, symmetric, and transitive, that we're going to focus on now. All right, so the reflexive property is whenever two things look exactly the same on either side of the equal sign, right? When you look at your reflection in a mirror, you look exactly like you. There's no difference. If your hair is up in real life, when you look in the mirror, your hair is not going to be down, right? It's going to be exactly like you are in real life. So when both sides look exactly the same, that's the reflexive property. So for example, the measure of angle 1 equals the measure of angle 1. They look exactly the same. AB equals AB. That's the reflexive property. The symmetric property seems like it'd be the same, right? If two things are symmetric, they're like the same. However, it's not. The symmetric property says that we can basically flip-flop both sides of the equal sign. So if AB equals CD, then we can just flip-flop them and say CD equals AB. Doesn't seem like a big deal, but when we start working on geometric proofs, it is going to end up mattering. So just understand, symmetric is not when both sides look exactly the same, but it's when we just flip-flop the order. So if A equals B, then B equals A, same difference. If angle 1 equals angle 2, then we could flip-flop them and say that angle 2 equals angle 1. That's the symmetric. And then the last one is transitive. This is kind of the easiest one out of the three to remember because it cuts out the middleman. There are three parts and the middle guy doesn't matter, so we cut him out. So basically you want to think of it this way. If I always like money terms, right? If a paper dollar equals, I don't know, 10 dimes, and 10 dimes is the same thing as 100 pennies, then we can just cut out the middleman, cut out the dime part, and say that a paper dollar equals 100 pennies. We just cut out the middleman. So the transitive property says if A equals B and B also equals C, then just cut out B in the middle and just say that A equals C, right? We just cut out this middleman. Okay, so if segment AB is equal to CD, and then that same segment CD is also equal to EF, then we can just cut out this middle part and say that AB is equal to EF. That's all we're doing. If angle 1 equals angle 2 and angle 2 equals angle 3, then just cut out angle 2 and say that angle 1 equals angle 3. We're just cutting out the middleman. All right, example, write a two-column proof to verify the conjecture. Given angle 1 and angle 2 are congruent, the measure of angle 2 has to equal angle 3. Oh, no, sorry, this is the given. Angle 1 and angle 2 are equal, and angle 2 and angle 3 are equal. We have to prove that angle 1 is equal to angle 3. So we know that these two angles are equal. And we also know that angles 2 and 3 are equal. So we're trying to just cut out angle 2 altogether and prove that angle 1 and angle 3 are congruent. So in line 1, we have the given. In line 2, we have the given. Sometimes you can just write that all together in one step. You don't have to write it as number 2. You would just write both lines here, both pieces of the given in line 1, and you would just write given one time. That's fine. Or you could do it how they did it and list it out in 2 steps. It's the same difference either way. But what can we say after that? We can just cut out the middleman, say these two guys go away, and then we're left with angle 1 being equal to angle 3. So that's what we said in the 3rd step. What's our reason for being able to say that? The transitive property of equality. If angle 1 is the same as angle 2, and angle 2 is the same as angle 3, then angle 1 is the same as angle 3. Think about your friends, right? If you're 16, and your friend, let's say Tim, is 16, and Tim is the same age as Sarah, that means she's 16, right? So if you're the same age as Tim, Tim is the same age as Sarah, you can just cut out Tim and say that you're the same age as Sarah. You're just cutting out the middleman. All right. Exercise is at the bottom, and then I'll let you guys get to your assignment. State the property that justifies each statement. If the measure of angle 1 is equal to angle 2, then the measure of angle 2 is equal to angle 1. We just flip-flop the sides. 1 equals 2 and 2 equals 1. So the one up here that says we can flip-flop the sides is the symmetric property. So we're just going to write symmetric here. Okay, line 2. If angle 1 equals 90 and angle 2 equals angle 1, then angle 2 equals 90. Okay, so we have to be careful here because this looks like it could be transitive, right? But to be transitive, you literally have to have the exact same thing listed next to each other, right? Again, transitive is if A equals B and B equals C, then A equals C. This B is listed here in the middle. It's next to each other. We could just cut that out and say that A equals C. It has to be written that way to be transitive. So for number 2 here, if angle 1 equals 90 and angle 2 is equal to angle 1, then angle 2 equals 90. This is not transitive. 90 and 2, they're not the same. 1 and 2, they're not the same. They have to be exactly the same. So the only other thing this could be is substitution. If the measure of angle 1 is 90 and angle 1 and angle 2 are the same size, then we can take that 90 and put it in place of angle 1 and say that the measure of angle 2 equals 90, which we did here. That's substitution. 3, if AB is equal to RS and RS is equal to WI, then AB is equal to WI. This is transitive. Look, RS is right here in the middle together. We can just cut out that middleman and say that AB is equal to WY, which we do. So that's transitive. You're just cutting out the middleman. 4, if AB equals CD, then 1/2 of AB equals 1/2 of CD. So you could look at this 2 ways. You could either say that we multiplied both sides of our equal sign by 1/2, or you could say that we divided both sides of our equal sign by 2. Since they wrote it this way, it looks like a multiplication problem, so I'm going to say this is the multiplication property of equality. Prop of equality. But if you said this is the division property of equality, you wouldn't be wrong because you are actually just dividing both sides by 2 when you take half. All right, number 5. If angle 1 plus angle 2 equals 110, and angle 2 is equal to angle 3, then angle 1 and angle 3 equals 110. Careful again with transitive. Remember up here, RS and RS was next to each other. The only thing between them was the word and. So for this to be transitive, we have to have 2 of the same thing next to each other. 1 and 2 are not the same. 2 and 110 are not the same. 110 and 2 not the same. 2 and 3 not the same. 3 and 1 not the same. 1 and 3 not the same. 3 and 1, 10. Nothing is right next to each other, so this cannot be transitive. But what can it be? Angle 1 plus 2 is 110. Angle 2 is the same as angle 3. So what if, in this first statement, I took out angle 2 and I replaced it with angle 3? Angle 1 plus angle 3 equals 110, which is what they say here. That's substitution. When I replace something in math that has the same equal value. I'm just making it look different. I'm not changing the value. That's always substitution. Here, I just changed angle 2 to angle 3 because it told me that they're the same size. So I made it look different, but it didn't change the value of anything. Number 6, RS is equal to RS. Which property says that both sides of the equal sign look exactly the same? This first guy, reflexive. You look just like your reflection in the mirror. I always used to say if you're like pretty in real life, you're not going to be ugly in the mirror. I don't know why I said that. It was kind of dumb. But you look exactly like your reflection. Reflexive property, both sides look exactly the same. 7, if AB is equal to RS and TU is equal to WY, then AB plus TU is equal to RS plus WY. What? This is kind of like a two-parter, but we could cut to the chase, right? Basically, I have 2 things are equal, right? These 2 things are equal, and these 2 things are equal. So if I add AB plus this first one, that's going to be the same thing as adding this guy plus this second one, because this whole thing is equal to this whole thing. So I'm taking the first parts and adding them together, and that should be the same thing as the second parts added together. right? Because you could say that maybe they're equal. Maybe AB is 5 and maybe TU is 5. And then maybe RS is, I don't know, X, and WY is X. This isn't really going the way I thought it was going to go. Well, anyways, if I added the first two together, it's going to be equal to the second two, right? If these are equal, that means X is 5. So if I add 5 and 5, that's 10. It would be the same thing as adding 5 and 5 here, which would be 10. Any way you shake it, they're going to be equal. So this is, we could say, the addition property of equality. There's also substitution, you could say, in there, but we are adding, and we're adding the same thing, the same value on both sides of the equal sign. So we'll say definitely the addition property. You could word it so that you fit substitution in there. Okay, number 8. If the measure of angle 1 is equal to angle 2, and angle 2 is equal to angle 3, then angle 1 is equal to angle 3. Guess what we have? Middlemen, exact same thing. So we can just cut them out and say that angle 1 is equal to angle 3, which we do right here. So that's the transitive property. And then lastly, number 9. If the formula for the area of a triangle is A equals 1/2 times base times height, then base times height is equal to 2 times the area of the triangle. Write a 2-column proof to verify the conjecture. Excuse me. So we said the area of a triangle equals 1/2 base times height, and they're saying then BH equals 2 times the area of a triangle. Right? So this is our given. This is our proof. So we just want to write that out in a 2-column proof. So we have our statements, our reasons, make a T-chart. Doesn't have to always be pretty. Mine's definitely not. All right, number 1 is always the given. So given that A equals 1/2 BH, and my reason, why did I use that? Because that's what was given to me. What's the next thing I can do? What am I trying to show? That BH by itself equals 2A. So how do I get BH by itself? What do I need to do to both sides of the equal sign to get rid of times 1/2? Well, to get rid of a fraction, you multiply by the reciprocal, right? So if I flipped 1/2 upside down, that's just 2 over 1. So to get rid of 1 over 2, I have to multiply by 2 over 1, which is just 2. So I'm going to multiply the left side of the equal sign by 2 and the right side of the equal sign by 2. And since I multiplied both sides by 2, that's the multiplication property of equality. Okay, now I actually have to multiply in step 3. I'm just going to simplify. That I have 2A equals, and then 1/2 times 2 is just 2 over 2, which is 1, which goes away, and I'm just left with BH. And my reason there is all I did was simplify, so that's substitution. And I have to stop whenever I get to my proof. Is this my proof? Am I trying to prove? Yeah, that's what it told me to prove, right? If A equals 1/2 BH, then BH equals 2A. Is that what I said here? Yeah, 2A equals BH. We could even flip-flop it. Let's do that because it tells us to make sure BH is equal to 2A. So let's take it a step further. All we're going to do is flip-flop both sides and say BH equals 2A. And what property is on this sheet of paper, on this side, that says everything's still equal if I just flip-flop the two sides of my equal sign? The symmetric property, right? If AB equals CD, then CD equals AB. Same thing, I can flip-flop both sides. So since I just flip-flop both sides, this is the symmetric property. I think I left out an E in there, it's supposed to be at 2 M's there. Okay, so that's our proof. We got to our proof. This looks exactly like what it told me to prove up here. then prove this. So I'm done. Hopefully that helped you a little bit. You'll have a worksheet to try. It's the same kind of stuff. It's not any more difficult, but you will need to get used to especially these three properties, but also the other properties listed on the front along with them. These are the three on the back, and then all these properties of equality, the four, substitution, and distributive property. Okay, let me know what questions you have.